Episode 1 ended with a promise: join the slices. So we did, and the lattice broke, exactly where the theory says breaks are diagnostic. But before that, the framework did something I need to tell you about, because it is the reason this whole series exists. It corrected me. Its reviewer. I made a claim about the joined data, and the framework's own typing discipline said, no, that computation lives in the wrong lattice. The machine kept the human honest. That is the self-correcting loop biting the right person, and it is the best result this program has produced. This is the Rosetta Calculus, Episode 2, the first real data break. First, the receipts, because nothing in this series enters without them. The checkpoint is frozen on the Book 7 branch, 18 tests passing on a clean clone of the exact commit. Every evidence hash matches the Causal Lab's frozen record. The Causal 9 matrix, the 9B contract, all of it, byte for byte. And the discipline is written into the file itself. Frozen evidence was read-only, nothing rerun, nothing moved, nothing normalized to fit the mathematics. Plus one rule that carries the whole episode. A missing coordinate is not encoded as false. False means the evidence supports failure. Unknown means the experiment never tested it. Collapsing those two would manufacture lattice points that were never observed. That rule is why everything that follows is honest. Then the local axes. 7 bounded 2-case slices from the frozen matrices: issuer identity, algorithm binding, role authorization, task binding, rotation validity. Each one classifies as a distributive 2-element lattice in its declared subspace. Honest scope, stated on screen, 2 elements is the degenerate case. A 2-element chain is a lattice by definition. These results validate the pipeline, not the structure. That sentence is what separates this series from every AI research video on the internet. The claim is stated at exactly the strength the data supports, no more. Now the break, the first real multi-axis result. For Causal 9, 5 coordinates are directly evidenced across all 5 cases, 4 unique observed signatures. And the classification, joined semilattice, not a lattice. 3 meets are missing, the combinations of signature validity with algorithm, with task binding, and issuer identity alone. None of those signatures appears anywhere in the frozen matrix. And here is the part that makes this Book 6 style science instead of Book 7 style algebra. The missing meets correspond exactly to untested joint failure combinations. The experiment never ran a case where issuer failure combined with stale task binding or algorithm failure with another independent failure. So the break may be a coverage gap, not a structural impossibility. The mathematics does not know which, and the checkpoint refuses to pretend it does. Then the global question, join all 4 experiment families, Causal 8, 9, 9B, and the trust divergence prediction. The framework checked their common coordinate domains. The intersection is empty. So the honest classification of the 4 experiment union is a single word, underdetermined. Not lattice, not semilattice, not posit, underdetermined. And the checkpoint names the trap it refused to fall into. You could build a 3-valued product that orders knowledge about constraints, but that blurs 2 lattices that must stay separate. LB, what could be true? LC, what would be admissible? Knowledge and admissibility are different objects. That is the correction I mentioned at the start. My own first computation of the join did exactly the forbidden thing, and the framework caught it, in writing, in the frozen record. Underdetermined is not a failure of the program. It is the program working. And out of the break comes the next experiment, not chosen, predicted. The checkpoint freezes a new gate. Before combining heterogeneous slices, you need a shared coordinate domain, or bridging observations, or an explicitly labeled gluing rule. And the next step is prospective, not retrospective. Freeze predictions for the 3 missing meet states before running any new cases. Predict first, observe second, compare third. If the predicted signatures appear when the joint failure cases run, the coverage gap explanation wins. If they do not, the missing meets are structural, and that is a finding of an entirely different weight. Either way, the next episode is written by evidence that does not exist yet. Where the series stands, 7 clean local axes, 1 multi-axis break, honestly classified, 1 global claim, honestly refused, 1 reviewer corrected by his own framework, and 1 next experiment predicted in advance. The rule from episode 1 still holds, and it just got its first public proof. No result claimed stronger than its evidence, and the framework now enforces it against its own author. That is what it means to build a self-correcting system in public. And now, the quiz. Series quiz. When the framework joined all 4 experiment families, what did it classify the global structure as? A. A lattice. B. A joined semilattice. C. A posette. D. Underdetermined. 5 seconds. The answer is D. Underdetermined. The 4 experiments share no common coordinate, so no single classification is earned. And the framework refused to guess, because guessing would blur LB and LC, knowledge and admissibility. Underdetermined is not a failure. It is the most honest answer mathematics can give, and it is the one the framework chose. How'd you do? Drop your score in the comments. I'm Sean David Ramsing. This is the Rosetta Calculus. Next episode, the predictions freeze, then the joint failure cases run.